Here we have another example, 2 sine squared theta minus 1 equals 0. Now, if you first look at it, I'm going to kind of talk about it two ways. I'm going to go pretty quickly, but when you first look at it, it sort of looks like the difference of two squares. And the only issue is, though, it's not the difference of two perfect squares. And that's why I always refrain from using that word perfect when doing a difference of two squares example. So just to remind everybody of what the difference of two squares is, that would be something like x squared minus 4, which you quickly factor using conjugates to x plus 2x minus 2. Or maybe 9x squared minus 25. And again, you can quickly factor that, again, using conjugates. That would be 3x plus 5 and 3x minus 5. Maybe you have a different example, so I'm going to kind of boost it up a notch, all right? What if I had x squared minus 3? If I had x squared minus 3, it is the difference of two squares, just not perfect squares. If I wanted to factor this example here, I would do x plus x minus, and all I would write here is square root 3, because that's literally the square root of 3. It's square root 3. Done, okay? In calculus, there are many examples that I solve that where I factor this. Ooh, I'm a little low over here. I factor this using the difference of two squares. This might not look like it's factorable at all, but sometimes it does come in very handy, so store it in your brain somewhere. If I have x minus 1 and consider it as the difference of two squares, I could factor that. And that's for that. I can factor that how? Who wants to be a brave soul and try that out? Difference of two squares, if you think of it that way, put on your difference of two squares hat. If I use the same strategy that you use in these pretty straightforward ones, this little sneaky guy over here, how would I factor this? Raise your hand if you want to take a risk. Risk it for the biscuit. Not one soul. Ooh, I got one hand. All right. Go ahead, Zareen. What do you think?
Would it be maybe root x minus 1, root x plus 1?
Yep. Square root of x minus 1 and square root of x plus 1. Sorry, it's a little, I had to squeeze it in there. So if you were thinking that you're like, oh, I was going to say that, but I didn't want to be wrong. Well, you didn't risk it for the biscuit. Come on, guys. So we can still factor. Now, going here, could you solve this with factoring? Yes. Will most of you solve it with factoring? No. So I'm going to do that on the side. If I solved with factoring, I would have root 2 sine theta minus 1, root 2 sine theta plus 1 equals 0. And then I would solve from there. Root 2 sine theta minus 1 is 0. Root 2 sine theta equals 1, dot, dot, dot. Save the ending, so no spoilers just yet, because I'm pretty much betting most of you guys didn't try to factor it. Most of you guys probably, correct me if I'm wrong, added 1 to both sides, divided by 2, and took a square root. True? Makai, is that how you did it?
No, I did it how you did it, but I used 2, like in my parentheses, I had 2 sine theta plus 1 and 2 sine theta.
Okay, so that kind of got you a little messed up, because 2 times 2 would have been 4. That would be right. And that's what I was worried. A lot of people, when I see people solve this, by accident, they write x plus 3x minus 3. Because like, it's that same thing I talk about a couple times where I'm like, your brain does autocorrect like a text message, right? Where if it's not what you want it to be, your brain is like, it's this now. Because this would be convenient, you know, your brain just does what it wants to do. So not bad. I like that you tried to factor it. The rest of you guys, did you mostly solve the way I was just describing? Add 1, divide by 2? Yeah. Okay. Yeah. So if we did that, I'm just going to fast forward. Add 1, divide by 2. We get sine squared theta is a half. Then when we take the square root, I feel like we start losing people, because you stop that way of doing things where you're thinking about that next step and you're like persevering in your mind. So in your head, keep moving, okay? Don't get like deadlocked at like a spot. Bit by bit, I feel like this is where the light bulbs are going to go off for people if I had to guess. The square root of 1 is 1. Square root of 2 is square root 2. We rationalize, because who does this? Ew, radicals in the denominator. That's so naughty in the math world. You go to math jail for that. So then we have sine theta equals positive and negative square root 2/2. Is this like an oh duh moment? Raise your hand button if this is like a oh duh. Just what? 1, 2, 3, 4. Well, that was like Christmas lights. They all just went off. Yeah. Okay. I just feel like you get like stuck here because you're like, who are you? And what are you doing in this problem? You don't belong here because you didn't recognize that it was this. Is that what happened for most of you? Yeah.
At least for me.
Yeah, I would guess that it was probably for most of you. Okay, so there you go. And then I think from there, you're pretty much good on your own. Where to sine what angle? So part A, theta equals between 0 and 2 pi. What are the angles? Who can give me someone I haven't heard from? Let's get some hands up so I hear your voice today. Make sure your voice box is not broken. Alex R, you want to give me one or two? And then so like other people could jump in.
I only know 1 pi over 4.
Okay, now remember, when they're all from the same like ratio, right? 2/2 is a ratio. They're gonna have the same denominators, so keep that in mind. Give me another one, Danny.
3 pi over 4.
Good, 3 pi over 4. Give me another one. Keep it moving. Claire.
5 pi over 4.
All right, Veronica. Another one.
7 pi over 4.
Good. Now these two are actually from when sine theta. I'm just going to kind of clarify where it came from. Equals positive root 2/2 because that's quadrant 1 and 2. And then these two are actually when sine of theta equals negative root 2/2. Because those are in quadrants 3 and 4. Now for part B, you didn't need to list 4 equations. Think about it. You could be more clever and you can consolidate. Think about those answers and think about how far apart they are from one another. Can you write me one general solution that will give me every answer that's up here and will give me every other angle that overlaps those, that's coterminal to those? Maybe you didn't do it when you did your homework, but right now you're having like an epiphany and you're like, oh wait, I could do this. All right, so give it some thought. And then Bianca, you want to try? What would the general solution be for this?
Would it be pi over 4 plus pi over 2k, where k is any integer?
Sure. Again, I don't know why I was right. N easy. Beautiful. Why is she right? Who can tell me why Bianca's correct? What is she doing to consolidate her answers? Go ahead, Chris.
All of those answers are exactly pi over 2 apart, or 2 pi over 4 to make it a little easier to process up there.
Sure. That was nice explanation. So pi over 4, if you add 2 pi over 4, I like that he referenced it with the common denominator because it does make it a little easier to see, like 1 to 3 to 5 to 7. So that's why in another example, how I said leave the denominators the same. Don't reduce. It does make it easier for you to see how things relate to each other. Because when they're reduced, you don't always see it, you know? So by leaving the common denominator everywhere, it does help you see things a little bit better. So this right here, they're all exactly in the middle of each quadrant. They're all 90 degrees apart or pi over 2 radians apart. If you wrote 4 equations, all plus 2 pi n, whatever, you're fine. Maybe you just saw it that you could write plus pi n and from pi over 4 you landed at 5, and then start here and added pi and you got that one, you did 2. Okay. But the most clean, compact equation for a general solution would be that one right over there. Okay. Any questions on this example before I go on? I see some hands up, but I don't know if they were up for participating. So just make sure no questions on this one. All right. So if that helped you kind of see how to do the problem and you're good on it and you don't need to watch this again, thumbs up, put it in the past, you learned it. And if you want to come watch it again at another time, put thumbs down. So you're like, wait, I have to watch this again because I was not good at this. Okay.